here is the video version of the practice final exam, because some of you keep using iPhones that don't react with Google Slides well, and Google Slides audio annotation was working perfectly, and now it's not, and it's ruining my really awesome show. So here's a standard video review. Carbon dioxide. The leaks may look like they're fun, but they're dangerous because you risk freezing. It stains everything. It is more dense than air, or it can kill you. Like, watch this, see this right there? It's because it can kill you. And the fact that it's low and dense doesn't matter. It stains everything. No, it actually cleans things. When sulfur burns, it is hazardous because it's hot, unlike other fires. It makes sulfur dioxide. It makes carbon dioxide. It is not hazardous at all. It is a trick question. Given that I put this down here, you would think you wouldn't pick carbon dioxide. It makes sulfur dioxide, which when you inhale it, turns to sulfuric acid in your lungs. Now, is this guy doing the right thing by wearing a cloth mask over his face when he breathes in an acidic gas? You can watch the video again if you don't remember. Now, when you watch this video, the alarm sounds for an annoyingly long time, like longer than my daughter's alarm clock in her bedroom that she sets to 5 in the morning, and she won't shut off when it goes off till it makes me get up early and shut off her alarm. Like, this thing is really annoying. And then it just starts going psss with a little bit of steam. So why does it wait so long with the alarm going off? And why does it's just like, then it just goes woof and fills the room. So I'm bringing in a guest speaker to give you the proper answer, because your job is to pick the stupidest answer on this list. So, yes, he was inviting me to talk about this answer. If you, it's just a fire alarm. Well, it's not a fire alarm because fire alarms don't dispense fog. So that is truly a very, very stupid answer. You would have to be dumb to think this was just an ordinary fire alarm. Almost as dumb as the person who picked C. Yeah? This slow spray? No, wait. I'm the idiot for a minute. Wait. Yes, see? This person is an nincompoop. This slow spray is a warning that it is for real, not a false alarm. No, how can it? It's an alarm. It will go off whether it's false or not. No, the correct answer would be B, to give you time to escape because you will suffocate. So if you picked A or B as the correct answer, you are not thinking too smart. But since you were supposed to pick the dumbest answer, then you would be the dumbest if you picked B, because that is the truth. Combustion. Which fuel combustion below cannot produce soot of any kind? Hydrogen burning in air, methane burning in air, a metal burning in air, and propane burning in air. This could be one of them Sesame Streets, which things that connect them all. But which one of these things ain't soot? Carbon dioxide, which it's a gas, but if you rub off the first two letters, I don't know, magnesium oxide or water. Does water make smoke? I don't know. Think you find the answer is hydrogen. Can't make smoke any kind. Look at that, smokeless. It's water. How's water smoke? That's the answer. It's in my video. Watch it. Complete and incomplete combustion. Your furnace runs on this chemical equation. CH4 plus O2 makes H2O and CO2. That's methane and oxygen will combust to form water and carbon dioxide. The only way for carbon monoxide and pure carbon to form in this reaction would be you would need to add actual carbon to the fire. would you put more fuel in the furnace than there is oxygen to combust it? Or could you add more oxygen, or lower, actually, the oxygen until there was insufficient oxygen to burn off the carbon into carbon dioxide? Well, if you think of this problem, you wish to make sure Mr. Carbon is burned CO2. So if you put more CH4s in, there would be plenty more Cs for the oxygen, so that would do it. And if you were to remove the oxygen altogether, then there'd be nothing here, and you would make lots of carbon and carbon monoxide, so either B or C would work. I love gold. Love everything about gold, the taste of it, the smell of it. Oh, wait a minute. I love gold, the smell of it, the taste of it. But so many properties of gold are misrepresented in the movies, and you can watch these two clips. Do people screw up its density, its weight, its softness, or its melting point? You can pick more than one that is misrepresented in the movies. I should know. I was in one. Well, each melting point is in the Drogo melted it over the campfire. I think not. Each density. What are they doing? Fighting with gold bricks. I can't pick one up with my left hand. Its softness. You can't stack gold 20 feet thick. You might as well try to stack donuts 20 feet high. It's too soft. It will smush. Its weight. How can you misrepresent something's weight? It's like, it's at 100 pounds, it was supposed to be 50. You can change the weight all you want. It's not a property. It's just how much you have. So all three, A, B, and D, are totally screwed up in movies. For once, I'd like to see a person not be able to pick up some gold. So I was in California, and I was trying to get a tan under a light bulb, and we were like riding some curls there, but it was just a cloudy day, so I wanted to get a tan. I told my friend we were going to get a tan under an old incandescent bulb. My folks are wild ones, and they hadn't replaced the lights in the house with LEDs because they're just rebels. And so we was comparing the light spectrum from ultraviolet through the visible light. I'm kind of like turning in between Matthew McConaughey and the surfer dude right now, and there's the infrared. So you see the little dotted line? That's your eyesight, and mine might be a little bit wider, but this is the brightness the incandescent bulb makes. So this is how bright the light is, and this is the color, the wavelength. You got to learn this stuff to be a surfer. So anyway, I think I'm definitely Matthew McConaughey now. I'm going to take my shirt off and talk to you about all this stuff. So anyway, the visible light here, and there's where the incandescent light peaks. So can you tan under a normal incandescent light bulb? Is the answer yes? The answer no? And is it yes, you can because the incandescent bulb makes lots of infrared, or no, because it makes no light in the ultraviolet at all? Which should be the correct one. Now, you might go, well, there's a yes here and a no there and a yes there and a no there, but these are more explained kind of yeses and no. So on any given test from a teacher, if there's like just a yes and then there's a yes, but it's complicated, you can probably write off this one here. So I think you'll find the answer is there's no ultraviolet light coming from an incandescent light bulb. So you can stay under that like a bearded dragon on a rock in the Arizona desert, and you just ain't gonna tan. What color of light is invisible but felt as heat? Like, are you all crazy here? And like, you let this child not know until she was a teenager what color of light is invisible but felt as heat? Well, you ain't know it's ultraviolet. Invisible light can't be invisible. Like, are we taking crazy pills? Now, what about near infrared or far infrared? I actually wouldn't ask you this question on the exam. This is just to get you to watch this video again. Well, if you recall, my cell phone could see the light coming off the television remote. But it took me that special $500 camera to see your body heat. So which one of these do you think we'd call near infrared? The one that I could do really cheap and easy with a camera that could